The question states, the following nucleotide sequence is found on the template strand of DNA. First, determine the amino acids of the protein encoded by using the provided genetic code, and then give the altered amino acid sequence of the protein that will be found in each of the following mutations. So the first step of this problem would be to figure out the mRNA sequence from the DNA template strand. So it's just basic base pairing rules, and you know A with T, and then it's uracil rather than thymine since it's the mRNA sequence, so U, and then you finished just doing all these. Okay, so now that you've done that and you know it makes sense since it starts with a start codon and ends with a stop codon. And then you determine the amino acid sequence from the mRNA sequence by using the genetic code chart, which can be found online or in the book. So the first codon, AUG, codes for methionine, MET. The second is this, and so on. And then stop. UGA is the stop codon. So this is your amino acid sequence from the unmutated DNA template. So the first question states, what would happen to the amino acid mRNA sequence if a transition was at nucleotide number 9? So a transition is either a pyrimidine being mutated to a pyrimidine or a purine being mutated to a purine. And this happens at nucleotide number 9, so 369, which is this one. So the mRNA sequence beforehand would be the same. Okay, and then it's a transition. So it's the guanine will be a transition mutation to an adenine since they're both purines. And then all the other ones would be the same since it doesn't alter the reading frame. And then again, you would use the genetic code to figure out what each codon codes for. So the first two rather, would be the same. And then the result of the mutation, it doesn't change the amino acid sequence. It still codes for glycine. And all the other ones remain the same as well. So this mutation resulted in no change. The second mutation is a transition at nucleotide number 13. So all the nucleotides before 13 will still be the exact same, 3, 6, 9, 12, 13, so it'll be in this one. So the mRNA sequence will remain the same up until that point. Okay, so it's a transition again, so it's also a purine to a purine since it's a G, so it would be changed to an A in the mRNA sequence. And everything after it will also remain the same. And again, use the genetic code to determine the amino acid sequence, which is the same up until the point of the mutation. And this mutation resulted in an early stop codon, as seen here. And so, third mutation is, so the result of this is early stop, which will most likely result in a non-functional protein. So the third mutation is a 1 nucleotide deletion at nucleotide number 4, which would be this one right here. So the first one would remain the same, and then this is a 1 nucleotide deletion, so it will alter the reading frame from this nucleotide and onwards. So every codon after this would be different. So it's a deletion, so this would change to UG ACC. And you can see the result of this. It alters the reading frame, and the last coded for nucleotide last coded for codon only has 2 nucleotides. So the deletion occurred at nucleotide number 4 right here. So the new reading frame would be TAC, and then the next codon would be GGC, and as seen here, GGC. And so basically it just shifts every one over. So the amino acid sequence, again, you use using the genetic code, and that is thymine pro. And as you can see, this is a completely, this codes for a different completely protein than the original. Since it altered the reading frame, this is the original, and as you can see, basically only the first one is still the same. The next mutation is a T2A transversion at nucleotide 14. So 3, 6, 9, 12, 13, 14, an inversion. And an inversion would be, in this case, a purine switched to a pyrimidine. So an A either to a thymine, or in this case, uracil, and then, or a cytosine. So the amino acid sequence will remain the same before nucleotide 14. So AUG, ACC, GGC, 3, 6, 9, 12. 14. So the amino acid sequence, again using a genetic code chart, would be and this is where the mutation occurs. Leucine, whereas it was originally 1, 2, 3, 4, 5, 1, 2, 3, 4, which was originally glutamine. And again, this results from a transversion, this T being mutated to a U, which is a pyrimidine to a purine. This one is an addition of TGC after nucleotide 9, so 369, and then TGC will be added right there. So as you can see, the resulting protein would be the exact same, besides the addition of threonine rather than having it not at all. So this may or may not alter the resulting protein depending on the structure and function of threonine and within the protein. And the final mutation is a transition at nucleotide 23. So a transition at 23 would be 3, 6, 9, 12, 15, 18, 21, 22, 23. Transition, so it's a cytosine in transition, so it's going to be a pyrimidine to a purine. Oh, I'm sorry, a transition, so it's going to be a pyrimidine to a pyrimidine, actually. So all the amino acids before that point will still remain the same. And as you can see, this still had no effect on the resulting protein. And that's it for this. Thank you.